For the do now practice problem number 1, we have a story problem. Adonis and Amelia are both reading the same book this month. Adonis has already read 60 pages and plans to read 6 pages per night. Amelia has already read 20 pages and plans to read 14 pages per night. After 3 days, who has read more pages in the book? Select the correct choice. Because I know for part B, I have to explain how I know. I am going to use this section to explain to you guys how I'm going to get the answer. First, I listed what my variables represent. I'm going to let X represent the number of days and Y represent the total pages read. Now I have written the equation that represents the number of pages Adonis reads. Y equals 60 plus 6X. So every day, Adonis reads 6 additional pages. So he has already read 60. So the total pages that Adonis has read depends on the number of days that have passed. So, for example, if 1 day has passed, we know Adonis has read 60 plus 6 times 1, which is 66 pages. If 2 days have passed, we know that Adonis has read 60 plus 6 times 2, which is 72 pages, because 6 times 2 is 12. 12 plus 60 is 72. If 3 days passes, 6 times 3 is 18. 60 plus 18 is 78. I've converted the equation to slope-intercept form, y equals mx plus b, because that is the standard. That is the form that I want the equation in when I solve this problem. Also, I'll write the equation for Amelia. So we have a similar equation for Amelia, y equals 20 plus 14x. Amelia has already read 20 pages and she will read 14 pages per night. So after 1 day, Amelia will have read 34 pages. That's 20 plus 14 times 1. 14 times 1 is 14. And then 14 plus 20 is 34. And then we continue with that pattern as the days increase. I have also written the equation for Amelia in slope-intercept form. So now I know the equation for both scholars, and all I have to do is substitute 3 for X, because X is the number of days, and then I will be able to determine the total pages read by both students. Okay, so here's what I did. I let X equal 3 days. And so I substituted 3 in the equation, in Adonis's equation, and I got 6 times 3 plus 60. So Y equals 18 plus 60. Therefore, in 3 days, Adonis will read 78 pages. I did a similar process for Amelia. So I let X equal 3 days. So I substituted 3 in the equation for X. So right here where you see the X, I substituted in 3. And so 14 times 3 is 42. And so 42 plus 20 is 62 pages. So after 3 days, Adonis has read more pages. So I will select Adonis. Part C asks, after how many days will Adonis and Amelia have read the same amount of pages? I know for part D, I have to show how I know, so I'm just going to show my work right here. So I have written the equation for Adonis and for Amelia, and I'm going to use the substitution method to solve this equation. So it's called substitution. Now, what I will do is I'm going to write equation 1. Then I wrote equation 1. Here it is right here. Then I'm going to substitute in the expression for y from equation 2 into equation 1. So it will look something like this. So I have 14x equal, no, 14x plus 20 equals 6x plus 60. And I like to keep my equal signs lined up, so I'm going to go ahead and move it over. So once again, look very closely. So this is my first equation, equation 1. I wrote that equation right here. Then I know that for equation 2, y is equal to 14x plus 20. So instead of writing y, I substituted in the expression that is equal to y for equation 2. Now I'm going to solve this equation for x. I now have a one variable equation that I can solve for x. I have rewritten line 2 over again, and now I have line 3. Now, I want to get x by itself. So first, I have to get all of my x's on the same side of the equation. So I need to get rid of this 6x. So I need to subtract 6x from both sides of my equation. Now I need to combine like terms. So when I combine like terms, 14x minus 6x is 8x. And that's where the 8x came from. I still have a 20 on the left side of my equation. On the right side of my equation, the 6x's canceled out, which is great. I wanted to get rid of the 6's on the right side of the equation. I'm still left with 60. Now I need to get my constants all on the right side of the equation. So I need to get rid of the 20 on the left side of the equation. In order to get rid of the 20 on the left side of the equation, I have to subtract 20 from both sides of the equation. I know this because the inverse operation for adding 20 is subtracting 20. And 20 minus 20 is 0. And on the left side, I will be left with 8x by itself. Now, when I combine like terms, the 20s cancel each other out because 20 minus 20 is 0. So I'm just left with this 8x on the left side. And 60 minus 20 is 40. I still need to isolate x. There is an 8 on the left side of the equation with x. And this 8 means 8 times x. The inverse of multiplying by 8 is dividing by 8. So I need to divide both sides of my equation by 8. As you can see, I've divided both sides of the equation by 8. 8x divided by 8 is just x because 8 over 8 is 1, and we're concerned about the value of x, just a single x. And then 40 divided by 8 is 5, so x equals 5. And we know we're talking about days, so 5 days. So after 5 days, Adonis and Amelia will have read the same amount of pages. So we can say 5 days. And you may be wondering, and say 5, that's the answer, just 5. We may be wondering, well, how many pages did they both read after 5 days? So in some instances, you will have to write the solution for the whole system. And this is just one more step. This is called write the solution. All right, so I need to write the solution. So this question luckily only asked me after how many days will Adonis and Amelia have read the same amount of pages. So we know that x equals 5 days, right? However, let's say the question asks how many days and what is the total number of pages they've read in that amount of time. So that will be like writing the solution. So I can actually go back to one of my equations. I just chose the first equation. It doesn't matter. I could choose the first or second equation. And I went ahead, chose the first equation here. I substituted in 5 for x, because I know in 5 days they will have read the same amount of pages. So I found out that y equals 30 plus 60, and then y equals 90. So in 5 days, they would have read 90 pages. The solution to this system is 5, comma 90. Okay. In 5 days, both scholars will have read 90 pages. The last thing that you need to do with a system is you need to check the solution. Well, we already know that in the first equation, this equation right here, x equal 5 and y equal 90, it works because we use this equation to find the 90. However, we need to go back to equation 2, substitute in 5 for x, and ensure that we get 90 for y. All right, so I'm showing you here where I actually checked the solution in the second equation to make sure the solution made the second equation true. And I found out that when I let x be equal to 5, I did in fact get 90 days. Therefore, this solution does work. And normally you just write 90 when you have the check. So it'd be like 90, 90, and 90. 90 equals 90. So we're all good when we check. So this is a check. This is correct. When you have a open response item for a system of equations, this is what they are checking to see. Number one, do you label the first equation? Do you label the second equation? Do you show the method that you're using? If it is substitution, you have to show all of your steps. They're looking to see that you actually show every single step and then write the solution and check the solution in the second equation. This will get you full credit on a systems equation when you're using substitution. And it's an open response where they ask you to explain how you got the answer.